Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 8 video on the chapter of parallelograms, where I will discuss about trapezium and isosceles trapezium, its properties, its definition, and will finally solve 2 or 3 problems. If you have not watched the previous videos, part 1 to part 7, where I have discussed about the parallelograms, the squares, rectangles, rhombus, and have solved many problems based on assignment 1, then I will strongly suggest that you also watch those videos to maintain the continuity of your study on the chapter of parallelograms. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 8 video on trapezium and isosceles trapezium of the chapter of parallelograms. Okay, so I have prepared my rough notes on trapezium and isosceles trapezium that I will discuss and finally we'll solve 3 sample problems based on the properties of trapezium. Okay, so what is so we have already covered what is a parallelogram, what is the special figures of special type of quadrilaterals, that is a square, rhombus, rectangle. So trapezium is also a special type of quadrilateral where exactly one pair of opposite sides are parallel but they are unequal. So any quadrilateral having exactly one pair of opposite sides as parallel but unequal, then it is a trapezium. Please remember that the parallel sides need to be unequal, because if in a quadrilateral, if we have in a quadrilateral one pair of parallel sides and they are equal, it will become a parallelogram. So trapezium is not a parallelogram because it has exactly one pair of opposite sides, and so that pair of opposite sides need to be of a different length. So as you can see in the figure, ABCD is a parallelogram where the pair of opposite sides parallel are AB and DC. So what are the properties of a trapezium? First of all, the first property is that it will have exactly one pair of opposite lines sides which are parallel. So in this figure we are having AB is parallel to AB and DC. This pair of opposite sides are parallel, and also we will have that the parallel sides must be unequal, that is AB should not be equal to DC, that is AB is not equal to DC, because the moment AB becomes equal to DC, it will become a parallelogram, because in any quadrilateral, if one pair of opposite sides are parallel and equal, you will see that it will become a parallelogram, and trapezium is not a parallelogram. Okay, so we have this AB and the sides, opposite sides AB and DC are parallel and they are of unequal length. Also, since AB is parallel to DC, based on this fact, we will have two pair of adjacent sides which are supplementary, that is their sum will be 180 degree. So in this trapezium, this angle A and angle D are co-interior angles. They are actually co-interior angles because they are the adjacent angles on the same side of the transversal AD. So we will have angle A plus angle D is equal to 180 degree. That is, angle A and angle D are supplementary. Similarly, property 3 and 4 are same. Similarly, we will have for the other two angles B and C. So we will have so if A is x degree, just for example, if A is x degree, then D has to be 180 degree minus x degree. Similarly, we will have, since the angle B and C are co-interior angles, meaning angle B and angle C, they are angles on the same side of the transversal BC, and where BC is cutting the parallel sides AB and DC. So angle B and angle C are on the same side of the transversal. These two angles are co-interior angles. So their sum will be 180 degree. So we will have angle B plus angle C will also be equal to 180 degree. So if B is some angle y degree, then definitely angle C has to be 180 degree minus y degree. So these are the basic properties of fundamental properties of a trapezium. Remember that a trapezium is a quadrilateral having exactly one pair of opposite sides parallel, but they are unequal. The sides are not equal, they are unequal. And since the one pair of opposite sides are parallel, based on these facts, we are getting two pair of supplementary angles. One pair is angle A and angle D, the other pair is angle B and angle C. Okay, now let's quickly draw some trapezium. So first we need to have a pair of opposite sides which are parallel but unequal. So let's say this, and let's say these two sides. I'm roughly drawing my diagram will be very approximate. It is not accurate. So let's say AB, the sides AB and CD, these are the two opposite sides which are parallel and unequal, and then we can join AD and D. We can join A and D and B and C, and will give the trapezium ABCD. So AB is parallel to DC. Okay, let's see some more trapeziums. Let's say first we draw the two opposite parallel sides, but they are of unequal length. So let's say this is AB, and let's say this is AB and CD are the two parallel lines, the two opposite parallel sides, and they are of unequal length, and then we connect B and C. We connect BC and we form the side BC and AD. So we have DC is parallel to AB. So over here we have AB is parallel to DC, and of course AB is not equal to DC. And in the second figure we have DC parallel to AB, and of course AB not equal to DC. Let's see for few more figures. Let's say we are having the two opposite parallel sides, unequal parallel sides B. One is XY. Let's say this is XY, and let's say the other opposite parallel sides, unequal parallel sides B, XY, let's say W, Z. So now we connect YZ and WX to form the other sides. So we have XY is parallel to WZ. So over here, so this is a trapezium where XY is parallel to WZ and XY is not equal to WZ. I hope you got the idea how a trapezium will look like. Now there is a special case of a trapezium where in these three figures, as you can see, the non-parallel sides. So these in the first figure, AD and BC are the non-parallel sides and they are unequal. In the second figure also, AD and BC are the non-parallel sides and they are unequal. And also in the third figure, WX and YZ are the non-parallel sides, non-parallel opposite sides, and they are unequal. But in a trapezium, the non-parallel sides, the non-parallel opposite sides can be equal. For example, let's say we have this trapezium. So if this is a trapezium, let's say PQ RS, where the pair of opposite parallel sides are PQ and RS, and the non-parallel sides SP and QR, they are equal. So the non-parallel sides can be equal. May or may not be equal. Okay, but it is important that it has only one pair of opposite sides parallel, and those parallel sides should be of unequal length. Okay, so let's see what are the necessary conditions for a quadrilateral to be a trapezium. It is basically based on the directly related to its definition. So if in any quadrilateral we see exactly one pair of opposite sides are parallel and those parallel sides are unequal, we can say that that quadrilateral is a trapezium. So that was a trapezium. The next is isosceles trapezium, which is based on trapezium. That is, if we have an additional information in a trapezium that the non-parallel opposite sides are equal, then in a trapezium, if in a trapezium we have the non-parallel opposite sides equal, then it becomes an isosceles trapezium. So an isosceles trapezium is a trapezium. The additional criteria or the property is that the non-parallel opposite sides are equal, but they are still non-parallel, but they are equal. So as you can see in this figure, ABCD is a isosceles trapezium. The parallel sides are AB. the parallel sides, it has exactly one pair of opposite sides which are parallel. That is, we have so properties of an isosceles triangle. The first one is exactly one pair of opposite sides are parallel and equal. So as per this figure, we have AB is parallel to DC, and we must have AB is not equal to DC. They are of unequal length. Okay, this is based on the property or the definition of a trapezium. Now the second is non-parallel opposite sides are equal. So in this trapezium, the non-parallel sides are AD and BC. So we must have AD is equal to BC. This is the additional property of an isosceles trapezium. This property makes a trapezium an isosceles trapezium. That is, the non-parallel sides are equal. Now based on this, we have some more interesting properties or results. The third property says two pairs of adjacent angles are supplementary. This one is based on trapezium. As you can see in trapezium, we have property 3 and 4. The sum of the sum of A and D are an adjacent pair of angles. Similarly, B and C are an adjacent pair of another adjacent pair of angles. So their sum is will be equal to 180 degree, as they are angle A and D are co-interior angles based on the parallel sides AB and DC. Also, B and C are co-interior angles. Similarly, it will also be true for an isosceles trapezium, since at the end of the day an isosceles trapezium is also a trapezium. So we will have in this figure angle A plus angle D will be equal to 180 degree, and also we will have angle B plus angle C is equal to 180 degree based on this figure. Since AB is, we have assumed that in this trapezium AB is parallel to DC, and we have and the non-parallel sides are AD and BC, and they are equal. Okay, so we have this. The fourth and the fifth, the properties 4, 5, 6 are interesting. The property 4 says angles at both ends of the parallel sides are equal. Now, the parallel sides in a trapezium are also known as the base. So, the side AB and DC are base of the trapezium. So, for the base DC, for the base AB, the angles at the end are angle A and angle B. For the base AB, the angles at its two ends are the angles A and angle B, and they will be equal. So angle A will be equal to angle B. Similarly, for the base DC, that is the opposite side of the side AB, or the two opposite parallel sides, DC, for the base DC, the angles at its two ends, or the opposite angles at the opposite ends of the base DC are angle D and angle C. So they will also be equal. Angle D will also be equal to angle C. So we have angle D is equal to angle C. This is a very important property of an isosceles trapezium. Now, why are these? Why angle D is equal to angle C, and angle A is equal to angle B? This can be proved by using congruency of triangle. So what we need to do is that I will explain that later on. Let me first finish the properties. So the next property is that the diagonals are equal. This is also super important. The diagonals are equal. So the diagonals are AC and BD. So they are equal. So AC is equal to BD. The diagonals in an isosceles trapezium are equal. Okay. Another, let's say the diagonals intersect at the point O. The property 6 is that there are many results that if you can remember, it is fine. I think it is better to remember that this angle at the two parallel sides, that is the AB, the two opposite parallel sides, that is AB and DC, they are forming isosceles triangle at the point of intersection of the diagonals. That is this angle, let's say this angle be x degree. If this is x degree, then this angle will also be x degree. So I don't know how to name this property. I am writing the the results that angle ODC will be equal to angle OCD. That is the triangle formed on the parallel side DC with the point of intersection of the diagonals, that is O. So ODC, triangle ODC is an isosceles triangle. As you can see, triangle ODC is an isosceles triangle where angle ODC is equal to angle OCD. This implies that OD is equal to OC. That is, these two sides will be equal. Also, similarly, the same thing will happen. The same thing will happen for the triangle formed on the other parallel side, that is formed on the side parallel side AB. We will have this angle. Let's say if this angle is M and this angle is N, we will have angle OAB. Angle OAB will be equal to angle OBA. This implies that AO will be equal to OB. AO will be equal to OB. So this angle and this angle will be same. M and M, M and M. Both angles will be M, whatever that value of M is. M is an angle. Okay, so these are the properties of an isosceles trapezium. The thing that you must remember is that first of all, an isosceles trapezium is a trapezium. So all the properties of a trapezium will also be true for an isosceles trapezium. That is, exactly one pair of opposite sides are parallel and they are of unequal length. And also there are two pairs of adjacent angles that are supplementary. That is, in this figure, angle A and D are supplementary and angle B and C are supplementary. And then we will have, since it's an isosceles trapezium, the non-parallel sides are equal. That is, AD is equal to BC. And finally, we will have the two diagonals will be equal. That is, AC is equal to BC. AC is the two diagonals are equal. That is, AC is equal to BD. And then finally, we will have the angles at the end of the bases are equal. That is, angle D will be equal to angle C and angle A will be equal to angle B. These are the main properties of an isosceles trapezium. It is better if you can remember the properties 6. That is, at both the bases, by bases I mean the parallel sides AB and DC. AB is a base, DC is also a base. So AB, at base AB, and there is an isosceles triangle formed with the point of intersection of the diagonals, that is O. So, and the angles at the base are in the triangle AOB, the angles at the base are equal. That is, angle OAB is equal to angle OBA. Similarly, on the base DC, the isosceles triangle formed is ODC, where we will have angle ODC is equal to angle OCD. Okay. Now, let's try to draw some examples of isosceles trapezium. So, first we need two parallel sides, unequal parallel sides. We have to draw two parallel unequal sides such that the non-parallel sides are equal. So, let this be, this can be the two parallel sides which are of unequal length, two opposite parallel sides, and such that the non-parallel sides are equal. So, ABCD is an isosceles trapezium where AB is parallel to DC and AD is equal to BC. And of course, remember that angle D will be equal to angle C and angle A will be equal to angle B. And of course, the diagonals will be equal. Okay. let's see another isosceles trapezium. So we first draw the pair of opposite parallel sides but unequal. Let's say my drawing will be very approximate, it will not be perfect. So these are the two opposite parallel sides of unequal length. So hopefully these two sides are equal. So let's say PQ RS is the trapezium where PQ is parallel to SR. The pair of opposite sides PQ and SR, they are parallel to each other, but they are of unequal length, and the other opposite sides which are non-parallel, they are equal. Okay, I think these two figures will clarify what an isosceles trapezium will look like. So over here angle P will be equal to angle Q and angle S will be equal to angle R. Okay. Now necessary conditions for a quadrilateral to be a trapezium. When can we say that a quadrilateral is a trapezium? It is basically related to its definition only. If in a quadrilateral we see there is exactly one pair of opposite sides which are parallel but unequal length, then it will be a trapezium. And what is the necessary conditions for a quadrilateral to be an isosceles trapezium? The conditions for a trapezium, it will apply. Additionally, we can say that if the angles at both ends of a parallel side are equal, so for the necessary conditions for a quadrilateral to be a trapezium, so let's say we have if we have two sides parallel in a quadrilateral, if we have two sides parallel but of unequal length, then it will be a trapezium. So let's say AB and CD are the two we have found in a quadrilateral ABCD, the sides the opposite sides AB and CD, they are parallel but they are of unequal length. Then definitely the quadrilateral ABCD will be a trapezium. ABCD will be a trapezium. Now for the necessary conditions for a quadrilateral to be an isosceles trapezium is that if we have in a quadrilateral, let's say we have AB, in a quadrilateral ABCD, if we see that the side AB is parallel to its opposite sides CD, but they are of unequal length, and if we see that the quadrilateral ABCD, we see that the two angles at the ends of each base, that is AB is a base and DC is a base, if we see that AB is equal to A is equal to B, if A is equal to B, then also we can say that ABCD will be an isosceles trapezium. Let me think. If at least for any one side of the parallel side, if the angles at both the ends are equal, then can we say that it will be an isosceles trapezium? I think so. Even though I'm not really quite sure, but I think it will be. So this is, if we have this scenario, ABCD is a quadrilateral, AB is parallel to DC, AB and DC are the opposite pair of are opposite sides, and they are parallel and they are of unequal length. And so we have AB is parallel to DC and AB is not equal to DC, and we have angle A is equal to angle B. All this will imply that ABCD is an isosceles trapezium. Now, instead of the angles A and B, it could be the angles D and C also. If angle D is equal to angle C, then also we can say that ABCD will be an isosceles trapezium. Okay. Now let's solve few problems. The first problem says that ABCD is a rhombus. Why rhombus? ABCD is a rhombus such that AB parallel to CD. No. This should be trapezium. This is wrong. ABCD is a trapezium. I have incorrectly written the problem. So ABCD is a trapezium where it is given that AB is parallel to DC. Okay. Line segment AE is drawn on diagonal BD such that angle EAD is 36 degree. Okay, and angle BDC is 38 degree. If angle AEB is x degree, and angle EAB is y degree, then values of x and y respectively are. So we have to basically find the angle x and angle y. Okay. So angle x and angle y. Okay. So ABCD is a trapezium. So what can we have? So since it's a trapezium, we know that and it is given that AB is parallel to DC. Okay. This angle okay, so AB, we have AB is parallel to DC. Since it's a trapezium, these two sides, opposite sides are parallel. So definitely based on the fact, and we can say BD is a transversal. So we will have alternate interior angles will be equal. So we will have angle BDC should be equal to angle DBA, and angle BDC is given to be 38 degree. So we have so we can say that angle DBA, so this angle, this is also 38 degree. Okay. What else do we have? 36 degree and 38 degree. X degree. AB is parallel to DC. What? AB is parallel to DC. Okay, angle EAD is 36 degree and angle BDC is 38 degree. Okay. No other information is given. What else can we have? We will have angle D plus angle A will be, since they are co-interior angles, since DC is parallel to AB, we will have angle D plus angle A is equal to 180 degree. Also, we will have angle C plus angle B is equal to 180 degree. Angle A is 36 degree plus Y. $38. It's a trapezium. Okay. $38 degree. Let me quickly check if I am missing any other information given in the problem. Oh, okay. So I am indeed missing one information, and that is ADE. ADE is an isosceles triangle with AD is equal to AE. Okay. So this information was missing. I'm sorry. So it is also given that ADE is an isosceles triangle where AD is equal to AD. AD is equal to AE. So we have AD is equal to AE, since it is given triangle ADE is an isosceles triangle. Okay. So if we consider, so this angle, let this angle be Z degree. Since triangle ADE, since we have AD is equal to AE, these two angles will be equal. That is, the angles opposite to the equal sides in an isosceles triangle, they are equal. So these two angles will be equal. So we will have in triangle ADE, using the angle sum property, that is the sum of the angles of in a triangle is 180 degree, we will have 36 degree plus Z degree plus Z degree should be equal to 180 degree. So this implies 2Z degree will be equal to 180 degree minus 36 degree, which is equal to 4, 0 and 1. Sorry, 144 degree. So this implies Z degree is equal to 144 degree by 2, that is 72 degree. So we have Z degree is equal to 72 degree. Okay. Also we have Z degree plus X degree should be equal to 180 degree, as they are linear. Angle Z and angle X are linear pair of angles. So this implies Z degree is 72 degree. So 72 degree plus X degree is equal to 180 degree. So this implies X degree is equal to 180 degree minus 72 degree, which is 8 and 108 degree. So X degree is x degree is 108 degree. So x is 108. Now we need to find what is y. We need to find what is y. Okay. So so x is 108 degree. We need to find y. So in triangle, again applying the angle sum property in triangle AEB, we must have y degree plus 38 degree plus x degree should be equal to 180 degree. So this implies y degree plus 38 degree plus x is 108 degree should be equal to 180 degree. So this implies y degree is equal to 180 degree minus 38 plus 108 is 146 degree, which is equal to 30 which is equal to 34 degree. So y is coming to be 34 degree. The choices are okay. So we are getting x. So we are getting x is equal to 108 and y is equal to 34. Hence, the correct choice is it is asking then the values of x and y respectively are. So it should be 108, 34. So answer choice C is the correct choice. So this problem we applied the concept of the fact that trapezium has one pair of opposite sides are parallel. And yeah, that is all we used, and it was already given in the triangle ADE is isosceles triangle. So and one angle in triangle ADE is that is angle DAE is given to be 36 degree. So the other two angles will be easy to find applying the angle sum property. So once Z is found, we can easily find X because Z and X are linear pair of angles, and when X is found, we can definitely find Y applying the angle sum property in triangle AEB. Okay, let's see the next problem. ABCD is a trapezium where AB is parallel to DC. Okay, angle ABD is given to be 34 degree. Angle C is given to be 108 degree. If angle CDB is m degree and angle CBD is n degree, then values of m and n respectively are. So we have to find the values of the angles m and n. That is what is m degree. We have to find the values of m and n. Okay, so this is a trapezium. Okay. Okay, so since this is a trapezium, so we know it is given that DC is parallel to AB. This will imply that the co-interior angles, angle C and angle B, will be equal to 180 degree. These two angles are the pair of adjacent angles whose sum is 90 degree. We know that in a trapezium, there are two pairs of adjacent angles which are supplementary to each other. In this trapezium, one pair is angle D and A and the other pair is angle B and C. So we have angle C plus angle B is equal to 180 degree. This implies angle C is given to be 108 degree. And what is angle B? Angle B is nothing but 34 degree plus n degree. This is equal to 180 degree. So this implies 108 degree plus 34 degree plus n degree is equal to 180 degree. So this implies n degree plus 108 plus 34 is 142 degree is equal to 180 degree. So this implies n degree is equal to 180 degree minus 142 degree, which is equal to 38 degree. So the value of n is 38. That is, we can say from here n is equal to 38. We have to find m. Now once we have find n, it is easy to find m, because in triangle BDC, using the angle sum property, we will have m degree plus n degree plus 108 degree should be equal to 180 degree. That is, the sum of the three angles in a triangle is 180 degree. This implies n degree we know is 38 degree. So 38 degree plus 108 degree is equal to 180 degree. So this implies m degree plus 146 degree is equal to 180 degree. This implies m degree is equal to 180 degree minus 146 degree. This is equal to 34 degree. This implies m is equal to 34. So m is 34 and n is 38. So the correct choice will be, it is asking to find the values of m and n respectively. So it should be 34 comma 38. 34 comma 38. So choice A is the correct choice. Okay, let's see the next problem. I think this is the last problem. Okay. Problem 3. ABCD is a trapezium. ABCD is a trapezium where AB is parallel to CD. So it is given that AB is parallel to DC. AE is a straight line. AE is a straight line. Okay. So ABE are collinear, or the side AB has been extended to E. And in triangle CBF, there is a triangle CBF. CB is equal to CF. CB is equal to CF. So the triangle CBF is an isosceles triangle. Angle B, that is angle B of the trapezium is 64 degree. Angle CBE is equal to 44 degree. Angle CBE is not 44 degree. It will not be angle CBE, but it will be FBE. It will be FBE. FBE is 44 degree. Now it is saying if angle CBF is x degree and angle DCF is y degree, then the values of x and y. Okay. First of all, ABCD is a trapezium. ABCD is a trapezium. Okay. So definitely we have to use, the only thing we can use from a trapezium is that it has one opposite sides are parallel, which is in this figure AB is parallel to DC. From here we only know that angle C plus angle B will be 180 degree, and also angle D and angle plus angle A will be 180 degree. So we know that DC is parallel to AB. So this will imply, and CB is a transversal. The side BC is a transversal to the parallel sides DC and AB. So we will have angle B plus angle C is equal to 180 degree. They are supplementary. Okay, this implies that angle C of the trapezium is given to be 64 degree, is equal to 180 degree. So from here we can get angle B is equal to 180 degree minus 64 degree. This is equal to 116 degree. So angle B is not angle B. Oh, sorry, this is wrong. This will be angle this is angle B is 64 degree and we have angle C. So angle C is 180 degree minus 64 degree, which is equal to 116 degree. Okay. Okay. Also, we will have 64 degree plus x degree plus 44 degree should be equal to 180 degree, as these angles are on the same side of the line AE at the point formed at the point B. So we have this. From there we can say 64 plus 144 is 128. No, not 128. 108 degree plus x degree is equal to 180 degree. This implies x degree is equal to 180 degree minus 108 degree. This is equal to 72 degree. So x degree is equal to we have to find the values of x and y. So we have found x. So x is equal to 72. X degree is equal to 72 degree. Okay. Now it is given that in the triangle CBF, it is given that CB is equal to CF. So this will imply that angle CBF is equal to angle CFB, which should be equal to x degree, which is equal to 72 degree. So x we have already found to be 72 degree. So this is also will be also x degree. Okay. So now in triangle CBF, applying the angle sum property, we will have let's say we will have angle BCF, angle BCF plus x degree is equal to 180 degree. So this implies angle BCF, x is 72 degree. So we will have 72 degree into 2, that is 144 degree, is equal to 180 degree. So this will imply angle BCF is equal to 180 degree minus 144 degree, which is equal to 36 degree. So angle BCF is 36 degree. Angle BCF is 36 degree. That is, this angle is 36 degree. Now, what is angle DCF? What is angle? Okay. Now it is asking what is y. Y degree is equal to angle. We have y degree is equal to angle C, that is angle C of the trapezium, angle C plus angle BCF of triangle BCF, angle BCF. This is equal to angle C, we know is 116 degree, and BCF is nothing, we have already found to be 36 degree. So this is equal to 152 degree. So y degree is equal to 152 degree. This implies that y is equal to 152. So we have found x to be 72 and y to be 152. So the answer should be 72 comma 152. 72 comma 152. So the correct choice is B. B is the correct choice. So with this, it comes to an end in the discussion of the trapezium and isosceles trapezium, their properties, and solving 3 problems based on the properties of trapezium and isosceles trapezium. Even though in these 3 problems there was no isosceles trapezium, all the 3 problems were based on simple trapezium. I hope this video will be beneficial to you in understanding the properties of trapezium and isosceles trapezium and applying its properties to solve problems, geometrical problems. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So the only figure or the only special type of quadrilateral that is left to be discussed is kite, which I will do in the next video, and then I will solve the problems of the 2 exercises from the textbook of author RS Aggarwal. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.